So let's start the community news. Don't be late. So you guys have a lot of time after that to do your talk. Welcome everybody. I will fix that. André is noticing about something, but I will fix that later. Anyway, so welcome for Alfresco Tech Talk Live 169. Crazy how much we have made already. We are today, so as usual, having a quick community news. Then we have the main talk. So Boudewijn and Hein are speaking about natural language interface for metadata queries. And sorry, I'm not sure how to pronounce well your first name. That's what we have with European culture in general, is that sometimes it's like Antoine, a lot of people don't know how to pronounce it. But anyway, I'm used to that. So let's speak about Community Live. That's the biggest thing Hyland is organizing every year. It's back to Las Vegas. Last year, it was somewhere in the US, but I know that it's regularly in Las Vegas, and so it's back to Las Vegas. We have a early bird up to the end of the month of June, and we have an additional code that you can see here that will give you an additional $100 off your registration from the early bird. So don't miss that. It's really a cool opportunity to join. I know that most of the attendees each year are mostly from North America, but if you have the opportunity to come from Europe, you will be able to meet André, for example, because I know he is attending, and I think he has a kind of workshop or something like that. I know that he's preparing stuff, at least. I'm not sure yet that I will go, because I'm not that technical guy that is really mandatory, but if there's room enough, maybe I will go. And also it's the opportunity to discover Las Vegas on duty. I mean, at least the trip, because of course, if you play in a casino, you cannot expense that. Depends of your policy, but I think it's for most European, it's not possible. Anyway, so don't forget that. It's really cool. It's really easy to find, communitylive.com. And then let's speak about traditional news. So all the Alfresco Tech Talk Live recordings are now available in YouTube, so not on an official Hyland or Alfresco channel, unfortunately. It's still complicated. To be honest, I'm still working with that, with marketing, but yeah, anyway. But yes, you can find them. It's actually on Helbroy's channel. You can see these very good two projects, one from Angel again, and both from Angel, sorry, to connect and stuff like that. So have a look at it. I will post the links into the chat after that. We have a couple of highlighting community projects. So Spring Boot application for long-term storage of Alfresco nodes, very interesting. CMIS connector for Convertigo. Another Alfresco connector, but for Axon IV. We have a C# SDK. Whoa. I have a joke about that. You know why Java developers wear glasses? Because they don't C#. Anyway, Ballerina connector for Alfresco, and AWS iService connector for Alfresco. Anyway, and no offense for Java developer, of course, it's just a joke. New blog posts on third-party platforms, so one on LinkedIn, mastering search, and the role of zero trust on FormTech's blog. This one is not transforming into a blog article, but it's again on LinkedIn, and it's automating PDF generation in Alfresco. So I will share again those links in the chat later. Last thing important for me, if you want to become like our speakers today, I would say a speaker for once, just once in the year, or a regular speaker, we like them too. Like Hein is giving at least one talk per year, and usually it's very interesting, very technical also. You can contact André and I. It's really easy, and don't be shy. We will also have, I think, a Tech Talk Live in Spanish end of August, so it will be a Wednesday also. And if you speak Spanish and you want to create and to be a speaker let's go. And if you speak Italian or German and you want to organize so a regular Tech Talk Live, or you want just to do one Tech Talk Live about what you do because you're not confident enough to do it in English like today, I mean, again, contact us. It's really easy to find André and I, and we will organize that with you. Today, so Hein, Boudewijn, welcome, and I stop my sharing, and I mean, you should be able now to have your screen on. And I will try to fix this mess with webcams and stuff like that, but I need to check how to do that. And I mute myself.
Okay, so you should see my screen now.
We see your screen.
Awesome. Okay, then let's get started. So what we did is we created a prototype for a natural language interface for metadata queries. And first, I want to talk a bit about why metadata is important. And then Boudewijn is going to take over, and he'll talk about what we did and how we did it. And we'll show you that it actually works. So, in my opinion, metadata is important, is very important. And why is that? Well, let's look at what metadata is. Metadata is data that provides information about other data, but it's not the content of the data itself. And I see roughly three, looking at the metadata that we see in use cases and that we have standard in Alfresco, I see roughly three types of metadata. The first is metadata that answers questions about the life cycle of the content, right? When was this added, by who, what's the version history, things like that. And then there are metadata items that talk about the physical properties of the item, right? What's the file type? How large is it? How many pages are in this in this document? What things like that. And the third set is properties that are about the content. So these are typically things that you would extract or infer through things like intelligent document processing. Like what's the end date of this contract, or what's the total amount of this invoice? That's a classic one. But also, many AI techniques are generating or inferring metadata of this type, like image description. Now, most of these things, almost all of these things, are questions that you can ask of the item, right? What's the file type? When was it last updated? What's the end date of this contract? And those are questions that you can have about the things that you have in your repository. And so metadata is for finding the right content, right? We tag content with metadata so that you can find it back, so that you can locate it, so that you can ask questions and get answers. And you might think in this era of AI, do we even need to record all that metadata? I think yes. And also, I think what I see is that AI is used to actually generate more metadata so that it becomes easier to find the content. So metadata is getting even more important, or more useful, to find the right content, if you will. So Alfresco has a flexible metadata system because metadata is important, split over types and aspects. And those two are sets of properties. And an item is exactly one type, But an item can have multiple aspects, and aspects are sets of properties, key value pairs, if you will, that can be assigned to items. Alfresco has many built-in aspects. Some are for for internal processes, but for instance, we have an EXIF aspect that holds information about images. And also the transformation service is used or can be used to extract metadata from a file. So for instance, if you upload a JPEG to Alfresco, it gets sent to the transformation service, and the transformation service extracts the metadata from the EXIF header that most JPEG images have, and that information is put in the EXIF aspect, and that aspect is assigned to the item. So you get that for free, right? So metadata that is in some kind of structured format inside the file, like the title of a PDF and things like that. You get those for free already assigned to your item. So that's great. If you can search using metadata to find the right content. Imagine we have this question: which photos were added by Hein last week, which are more than 1,000 pixels wide? Right? That could be something that you want to know about your content. But then, if I want to know that, I also have to know: do we have that metadata? Do we know? Is there a metadata item that contains the date when something was uploaded? What are those field names? Does the field have a certain format that it needs to be, like a date format or a list of allowed values? I have to know all of those things before I can do a metadata query to find this out. And then if I know the fields, I need to know the query syntax, right? How do we represent a time interval, right? Last week that has a start date or start point in time and an end point in time. How do we represent that? And we're asking for three things: photos uploaded by Hein last week, more than 1,000 pixels wide. So I have three clauses. How do I combine those into a single query? And that's not trivial. That's not, even hardcore users of Alfresco have trouble transforming this information, this natural language information need into a query. So I thought, can we think of something that translates that information need expressed in natural language into a metadata query? Wouldn't that be cool if we had something like that? So Boudewijn actually contacted me wanting to do a research internship for this. So we took a quick look together about the query languages that we have. AFTS has the advantage that it has more search options, but it has the disadvantage that it's Alfresco specific. CMIS is an open standard, so that's nice. We're about open standards here. And it looks like SQL. And our initial thought was, well, there are systems that translate a natural language information need into an SQL statement. Maybe we can use that. And also, because CMIS is an open standard, every repository can support CMIS queries. So if we choose CMIS, then the result of this research is also more widely applicable than just for Alfresco. So we chose CMIS to go with. And then you get something like this. Which photos were added by Hein last week, which are more than 1,000 pixels wide? So, what are the properties, the metadata properties that we have to look at? The author, the date of creation, and the image width. And then that needs to be transformed into this CMIS query. I don't know about you. I think of myself as a pretty smart person, but I would have trouble, writing this down and doing this query, right? So we build a prototype, but I say we, but Boudewijn built the prototype. So I'm going to stop sharing, and we'll switch to Boudewijn, who will talk about the work he did.
Yes, one moment. Oh, all right. Is it working? Can you see my screen?
Yes, we can.
Perfect. All right. So yes, I'm going to tell you about the prototype that we made. This is an overview of the entire solution. On the left side, you see the natural language request from the user. And then there is a whole bunch of steps in the middle, and eventually we end up with a CMIS query on the right. First, I'll briefly go over the entire pipeline, so you get a rough idea of what everything does. And then I'll give you a demonstration and go more into depth for each step. So we start in the top left with number 1, where we get the aspects and the types from the Alfresco model. Then we are a bit selective for the aspects and the types. We remove some of them that we don't need. And those that are left over, we take the properties from the aspects and the types and place them in a list. Then there is also some processing for the user request. And this is done by a large language model. In this case, we're using Qwen. And what it does, it looks at a request and it thinks, okay, can this request be answered with a single property, or do we need multiple properties to give an answer to the request? If we need multiple properties, so for the more complicated requests, we will split them up into sub-requests. All right, then we have our sub-requests, and we have a list of properties, and we embed both of them using nomic text embed. And we compare these embeddings, the 20 properties which have the embeddings which most closely resemble the request. We pick those out and place them in a list. And then we ask a large language model, all right, from the list of only 20 properties, which one do you think is fitting to answer our sub-request? So we have only a single property which we think can answer the request and a sub-request. Then we need to get the correct CMIS syntax. And for that, we will use our third large language model. And it creates a CMIS query, and that's exactly what we're looking for. And sometimes there is one extra additional step. If we split up the request here at the start, then we have multiple CMIS queries for every sub-request, and we need to combine them at the end to get one large CMIS query, one final step. All right, now for the demonstration. We start off with property pre-processing. The good thing about the step is that we only need to do it once. If we have a list of processed properties, then we can use it for every query again and again, and we don't need to look at it. We don't need to run it every time there is a user request. So for our prototype repository, it's more or less the default repository. we have roughly 140 aspects and 140 types at the start after our API call. And first, we will be filtering out all of the aspects and types that don't have any properties. They might have some function in the structure of the repository, but we're not really interested in searching for them. So we are left with roughly 90 aspects and a few less types than we started with. Then we do an additional step of processing. And this is looking whether the aspects and types are actually used in the database. There are quite a lot of aspects which are, for example, about a very specific file type. There are aspects which are describe an audio file. But if you don't have any audio files in your repository, the aspect is never used, so we don't really need to consider it. So what we do, the trick here, is we run a CMIS query, select everything from a certain aspect or type. If that returns any document, then we accept it and we keep it. But if it returns an error or it returns an empty list, then we disregard it. And as you can see from this table below, that really quite drastically reduces the amount of aspect we have and also the amount of types we have. So we are left with a much smaller and a lot more usable list of 18 aspects and 31 types. And in these aspects and types, for our example, there are a total of 217 properties. So we have a list of all those. And because we are looking for the right property to answer our user's request, it would be quite convenient if the descriptions of the properties are quite informative. Luckily, there are already descriptions for every single property, but some of them could use a little bit more description or a little bit, some additions. One of those is the created by property, which we'll also be using in our example. So on the left, you see the created by property as it is by default. It's just a very brief description, the authority who created this object. And for this property, I modified it a bit to have a slightly longer description and also to have a list of allowed values. And these are all the users of the repository. So it eventually has to pick from one of these 5 so that we end up with an actual user of the system. All right. So we have our list of properties. And with that list of properties, we will hope to answer a user request. The user request is also pre-processed. And for that, we use a large language model. In this case, we're using Qwen. Qwen is pretty good at logic, and logic is kind of what is needed to split the request into smaller requests. Okay, before I will explain you briefly, because we're using large language models 3 times in this whole process. And we use, for all of them, we have these steps. So first, we pick a base model from Ollama. That's Qwen 3 here. Ollama is a platform where you can pull models and run them locally. And then we adapt the base model a bit with a model file, and you can add a specific prompt, system prompt, and you can instruct the model, large language model, what it needs to do. So for this large language model, we can instruct it, all right, you're going to get a user request. If it is a big user request, which you need multiple properties for, please split it, and otherwise just return the original user request. In this model file, there's also some parameters you can tweak with. I didn't do too much of that. There's only one parameter which I changed a bit, which is the temperature. The temperature is about how creative the model is going to be. I set it to 0.2, which is fairly low, because I don't want the models to be too creative, because they might come up with crazy ideas that make the thing break. So yeah, keep it simple. Then, to improve the large language model results, it's really handy to give some examples. So I give like an example of this is a big request, and I would like you to split it like this. And I also give an example of a small request, an atomic request, and then I tell it, okay, please don't split this one. And then for the third input, it's the user input, and then it already kind of knows what to do, and you'll see a lot better results. And finally, as the output for the large language model, we ask for a JSON, because it's very structured, and you can separate the reasoning of the large language model from the actual result, which you can use later in the pipeline. All right, then I'm going to switch over to the code, and I'll show you this splitting step. So here we have our example request. It's the same one that we are familiar with. Photos from Hein from last week, more than 1,000 pixels wide. And if everything is going to work correctly, it should split it up into the three kind of properties that Hein already mentioned. All right, so yes, it's working. Very good. So we have our first sub request, which is about the author, documented by Hein Ragas. Second one is about the creation date. And the final one is about the pixel width. Very well. Imagine we have a shorter request. I really just came up with it, something like, give me images about penguins. Well, there's only one property which you would need to know for this, and yeah, that's the subject. It also like kind of adds the kind of property that you would need in between parentheses. And it doesn't change it, like it doesn't split it up. There's only a single request. So this is working quite well, but we'll stick with the previous example for the rest of the code. Right. Then for the next step, we have some sub requests. And we have a list of properties which we think we can answer those requests, or we can. But now the question is, okay, how do we find the right property? And to do that, we have two steps. The first thing we do is we embed all of the properties. This is also something that only needs to be done once, because you can save the embeddings for later. And the request does need to be embedded every time, but that's only a single request, so it goes pretty fast. And then we compare the embeddings. The embeddings are compared on cosine similarity, and that's a metric which looks at how similar vectors are, but it doesn't look at the size too much. And it's quite a fast and convenient way to get a list of properties which resemble the request a bit. So we get a list of 20 properties, so we're sure we're not missing the best one. That's the idea why we have a fairly large list still. And then we ask a large language model, all right, from that list of 20 properties which are a bit similar, please pick the best property so that we only have a single one and we can start focusing on creating the correct CMIS syntax. I'll also show you the code for this. I need to skip ahead a bit. Let's see, limit property list. That's the first thing. So here, x is 20. That's the amount of properties that we're interested in. And we see that for every sub request, it returns a list of 20 properties. Does so for the other ones as well. And if you take a look at the top ones, you see created by. It seems a very fitting property for something related to like the author or the creator. There's actually two created by properties. There's one for the folder and one for the document. Usually we're a lot more interested in the document one. And there are some other properties which are also a bit related to the request. So now with this list of 20, we will ask the large language model to select a single one. Yes, that should be this step. And because it's a large language model, it always takes a little bit of time. But it does provide some good results. Here we have a request and a single property, which we can use to answer the request. Very convenient. We have it for all three of them. All right, we move on to the final, or one of the final steps. And this is getting the right CMIS syntax. We do this in 2 steps. First, we convert everything which is related to a date. So everything time-related is converted. And there is a very useful module for that, which is Microsoft Recognizers. So we're going to be using that. And then after we converted all the dates, then we're going to create the rest of the CMIS query. But first, let's get into the date conversion. So this is the example of one of our sub-requests, which is related to a date, which images were made last week. But CMIS doesn't understand what this means. It needs to be in this kind of format. And it's really picky about it. Like, it needs to be year, then month, then day, and then the time down to like the milliseconds. And if you change only something a little bit, then the query doesn't work anymore. So you need to be quite mindful of the details for this part. And also something, so this format is called the ISO 8601 format. And because a lot of the time references that you use in natural language are, you need some kind of reference time from right now. So if you have like last week, you need to know what the time is right now. Otherwise, you don't know what the last week is. And we'll also be tackling that in the code. I will show you that specific function that does the date conversion. So as you can see here, this is the Microsoft recognizes text. That module is quite a sophisticated thing that we're using. And we have also date time, which is quite useful because we can get the time right now. So we get the time right now, convert it into the ISO format that we want. And we give that time to the Microsoft recognizers function as a reference time. Now, I'll show you with some examples what this does. So if there is a request which doesn't have anything to do with the date, it should just return the request as it is. Very good, no changes. However, if there is a request which is something to do with the date, so last week or January or today, or it can really be anything, then it will detect it and it will convert it into a time range. And by default, sometimes it converts it to an exact instance. For example, for today, it would only return a single day. But I changed it a little bit so it also does a range for that, because CMIS always works with ranges. So even for today, you would have, okay, the last minute of yesterday and the last minute of today, and then that's the entire today. Yeah, and you can see from last week, it converted into 9th of June till 16th of June. Well, this Monday was the 16th of June, and last Monday was the 9th. So it captures the whole week. That works very well. And it does so really fast, as you can see, like 0.0 seconds. It's amazing. If you're not losing LLMs, then things can go really fast sometimes. The only issue I had with this is that sometimes it's a little bit overly eager to select dates from text. So in our last sub-request, we have which photos have a width of more than 1,000 pixels. And we can all see, okay, there's nothing with a date in here. So it should just return it as it is. But it does not do that by default. It sees the 1,000 and it thinks, oh, this is a 4-digit number. That must be a year. So it's regarding it as the year 1000 and trying to capture everything between the year 1000 and 1001, which is not really something that we're interested in. Okay, but luckily we can prevent that with a little bit of extra code, where we can only consider the years 1900 and 2000. And so if we change the code like that, then it will stop regarding the 1000 as the year 1000. And we just get the normal sub-request back. Very good. So now that we have all the dates converted, we move on to the next part for the CMIS syntax. I'm not sure if you're also seeing this, probably not. So we have, the good thing about CMIS is that it's really structured, so it doesn't change too much. With SQL, you have a lot more options, like select something else than everything, or you can group and order. CMIS doesn't have all those fancy things. So we can quite clearly ask the large language model what kind of structure it should output. And there's two different kind of outputs. For the types, it's pretty straightforward. We select everything from the type. And then we have some restrictions on the properties in the where clause. For the aspects, it is slightly more convoluted because you can't select directly from an aspect. Instead, you need to select from a type and then join the type to the aspect. The good thing is every single CMIS document, every single type is a subtype of CMIS document. So we can always select everything from CMIS document and then join that to the aspect, and that will work out. Another convenient thing about the Alfresco structure is that every document has an object ID. So we can always join the aspect with the object ID, and that will always work out. And then we can go into the properties of the aspect. All right. I'll also show this step in the code. Let's see. We go to query generation. And now for each of the sub-requests, it gets as an input a single property and the request, and then we obtain the correct CMIS query, or at least it looks correct to me. Now we have 3 separate CMIS queries, which is nice, but we need to combine them some way. And I'll give you a quick demonstration of how that is done. It is a rather complex function, but it is only using regular expressions and if statements, which means it can also be pretty fast. It's, again, the advantage of not using large language models. Everything goes super fast. So first, we use a regular expression to split up the CMIS queries into the different parts, different clauses. So we have all the where clauses, the types which is from, and the joins. And then we're going to construct the combined query. So the first thing we need for the combined query is the main type that we're selecting from, primary type. In this case, we have a slightly boring example because there's 3 types and they're all the same. It's all CMIS document. So that's the only thing we can select. We're selecting CMIS document. And then the next part is the interesting part of the whole function, and that is the joins that it's going to do. The required joins, which is a list, and it has every other type which is not like the primary type. So if this request was about some other type, then it would also be in the required joins. And also has all the aspects. And if there were like multiple aspects with the same name, they would also be combined here. And then for each item in that list of required joins, there would be a unique alias created. And then all of these, everything in that list is joined to the primary type by going for the object ID again between the alias from the primary type and from the required joins. And then the final step is combining all the where clauses with ands. And there we have the final combined query. I'll also show you this running in the code. So as you can see, this is some very simple code. If there are multiple sub-requests, now if there is only one sub-request, we just pick the first one and then we're done. But if there are multiple, we use the combine queries function, which runs really fast. Bam, 0 seconds. And we obtain a single query, which looks pretty good. There's a select, from, a where with everything, the author, the last modification date, and the pixel dimension. So I would say this is a correct CMIS query. But I am not entirely sure, because CMIS queries, any query language, in fact, if you only make a tiny mistake, like a comma at the wrong time, or one character can be wrong, and then the query doesn't work. So how do we know whether this query is actually working? Well, I thought of something for that. On the local Alfresco server, I created a user called Hein Ragas. And last week, I created I uploaded an image, which was pretty big. So I would say it has like more than 1,000 pixels in the width. So if we run this combined query on the local Alfresco server, this is the query, we get a list. It has a single item, and the item is demonstration.jpg. So the CMIS query is working. That's the great part. Oh, no, I went to the wrong, this thing. Yes, in conclusion, we have a prototype which works pretty well. There are a lot of requests that it works on. We even, Hein made a custom type about contracts, and we tested it on those contracts, even though it was like in none of the examples given for the LLMs. And it still worked pretty well for the queries that we came up with. So it is quite promising. It doesn't work all the time, though, because they're large language models. They are a bit unreliable, and sometimes they come up with queries that just don't run or don't make sense too much. Then there are some things which shows and some reflection on the whole process. So for the selection of the LLMs, I started out with Mistral 7b for everything. I had heard that it was good at creating SQL queries, and CMIS queries look very similar. So I thought, let's use that one for everything. But then it made some really illogical steps at the splitting part, and I was a bit unsatisfied with that. So I looked which large language model is really good at logic, and came up with Qwen, which does it really well. So I'm quite happy with that. For the selection part, I was also using Mistral 7b, but I wasn't too happy about it. I just tried some other model, OpenChat. It seemed to work better, like kind of through trial and error, ended up with that one. For the parameters, I didn't tweak too much with it. There could be something to be gained there. Maybe if you had a slightly lower temperature or some of the other parameters was different, you could get some better results. I have not really looked into that too much. Yeah, it's also quite important to give the right examples to the large language model. And sometimes even to know how exactly to formulate what you want to get from the large language model. For example, for like the splitting part, it really helped for me when I figured out that, all right, so there are two kind of requests. There are composite requests, which are you need multiple properties to answer, and there are atomic requests, which you can answer with only a single property. And finding those words, composite and atomic, it kind of helped me, and also, yeah, to get the right output from Qwen. And lastly, there is to consider time versus accuracy. These models are all pretty small, like 7 billion parameters is actually pretty small for a large language model. If you have a model such as ChatGPT-4, it is estimated to have about 1,800 billion parameters, which is way more. But it would also take more time, more computational power. Yeah, but it is, if you want more accurate results, then throwing a bit more advanced models at it would probably also help. Lastly, well, we have a very nice prototype, and it's working quite well. But what's sometimes even more interesting is the things that did not work, because you can learn from that. So one of the things I tried was combining these two steps, splitting and the selection. I figured maybe if you give a large language model a list of all the properties, and then the user request, and then ask it, all right, can you find all of the properties that need from the list of properties and use it to answer the user request. But it was not really good at this. Like, it was a bit too much for the large language model to do in one step. Even when I used a bit more advanced large language models, I was quite disappointed with the results. It was not consistent at all. So I kind of gave up on that idea and chose to do smaller steps, which worked pretty well. And also, as Hein mentioned, first we're looking into natural language to SQL methods, because CMIS is almost SQL, or looks very much like it. And SQL is used so much that you must have methods which already do this kind of thing. Well, I tried some, but I was not really that happy with the results. First of all, like, it was a bit tricky to convert the properties, the metadata properties, into something of SQL tables. And usually this kind of like natural language to SQL methods are made more for large tables and not for really picking the exact right property, because some properties are pretty similar. And I was quite unhappy that it usually doesn't pick the exact property that I wanted it to pick. And this also, this allows for a bit more customization to get it to do exactly what you want. And finally, if you end up with an SQL query, it doesn't always work for CMIS, because CMIS is quite a lot simpler. So you would also need to make sure that the SQL query you end up with it also is converted again into something that definitely can be used with CMIS, which was just a bit too much of a hassle. All right, so for the final part of the presentation, I'm going to give the word back to Hein.
Thank you, Boudewijn. So where do we go from here? You're still sharing your screen, Boudewijn? Oh, okay. Yeah.
My bad.
No, that's okay. That's okay. I'll just do the thing without a slide, because it was just a single slide. Where do we go from here? It's a prototype. It works, but it's a prototype. There are many ways that we could extend it. Maybe get some actual use cases in there. Do some experiments with actual repositories. But ultimately, wouldn't it be cool if we could package this up as a service and integrate it with the digital workspace? That's the point on the horizon. And then extend to different capabilities. So, for instance, as Angel remarked, the aspect versionable. Can we make a version of a new document? We discard that right now because it doesn't have any properties and doesn't fit with this. Maybe we should extend it, the prototype, to be able to cope with that. So there are lots of possibilities to extend it to other repositories, extend it to other query language. Those are all things that we can look at. But for now, I think we made something really cool, and that was what we had to share about it.
Yeah, that was a very interesting, I would say, demo with new aspects. Guys, we have 10 minutes to answer Q question. So some of them are from Angel. Angel, are you here? Do you want to ask? Enable your microphone and camera and ask your question, live, or do you want me to read them? But I guess, you're better than me to explain what you want to know. Up to you. But I will start with Alexis Germain question. So, will it be possible to perform some form of post-processing using a solution like this? For example, suppose I want to retrieve all documents created by Hein that are larger than 1000 pixels and have a different file names, metadata names. currently, to achieve something like a distinct operation, we need to query all the documents and then perform the comparison on the client side. Does this interface solution can provide a way to handle such cases directly without relying on client-side filtering? Let's say, take advantage of Hive to do the filtering on the backend.
Okay, that's an interesting one.
Yeah, it's a long one, but it's an interesting one.
Yeah. So the goal of the prototype was to translate a natural language query into a metadata query. So we did not target things that could not be expressed as a metadata query. I think, we have this. We could chain other things on top of it, and I think this is an interesting example of how we could extend the solution. But it's interesting. It hadn't occurred to me yet that this is something that we could want to add to this.
So a nice feature request, I would say.
Yes. Yes.
So this one, I will mark it as answer live. So one of the questions by Angel was, why don't you use the MCP tool? I mean, this protocol that a lot of people are adopting. Do you have a plan to evolve in this direction? Or, you found a good reason why to not use this protocol?
Boudewijn, do you want to add in on that?
No, I'm sorry. I'm not sure what an MCP tool is. So.
Okay.
It's this model protocol. Who released it? Anthropic, I think.
Model context protocol. So a description, a model-facing description of the API or the capabilities of a certain tool, so that the model can decide, which tools to use. We are working. Well, I know that there are several MCP servers out there for Alfresco. We are working on a, let's say, Hyland official MCP server. I don't know. This could be one of the tools, because also we don't rely on a single large language model to do all of these steps, because we found that the results were not that successful. And you've seen also in Boudewijn's code that he just uses Python code to combine statements, etc., etc. So I guess this whole chain could be a tool in an MCP server. But I don't think that an MCP server could replace this whole code chain.
Yeah, it would be on the back end anyway.
Yes.
Okay, very interesting. Alexis says thank you. Angel was suggesting that maybe adding more memory to the chat interface would help with, difficult requests. I don't know what you think. What were the limitations? It's running locally. You are using some VMs on AWS or something like that. So maybe if it's locally, you depend on the RAM you have on your laptop, indeed. But what do you think? Could we improve, the accuracy with, I would say, a more performant hardware?
Yes. Yeah. Well, I expect the more advanced large language model will probably give better results than the simple ones. Where is it going with this?
But so the demo that we viewed was all running on locally on your desktop machine, Boudewijn.
Yes, exactly.
Yeah. I mean, is it a beast of hardware, or is it?
No, not really. It's like it's a gaming PC, but only for not extremely advanced games. Like
yeah, no, you don't have 1 teraoctet of RAM or stuff like that.
No.
Okay, but it's a good gaming PC. I mean, at least. So.
Yeah. Oh, yeah. And also something I wanted to mention is like we got the whole prototype and we kind of got it working, but we really haven't really tested any accuracy, or like we don't have any percentages of like, oh, it works 90% of the time. Okay. It was just like a rough estimate. I don't actually know how well it performs.
That's a prototype. I mean, you're working on it, and so that's nice stuff. Okay, this one's done. Another answer is, well, I don't really understand the question, was from Angel at the beginning of the presentation. Why excluding aspects without properties? You're restricting queries this way. Imagine you want to retrieve documents that are versionable, aspect, together with some other criteria. What's the reason behind this decision? Maybe it's just a prototype and it's another good idea, but
so frankly, it simply hadn't occurred to me. So the versionable aspect, if it's assigned to something, then that something can have multiple versions.
Yeah.
But the versionable aspect itself does not have any properties. Okay. So you would only query the presence of the aspect rather than a property from the aspect. I think that would be an interesting addition. But also I think there are aspects like that which govern, let's say, the working of Alfresco, that may not be, useful as a user-facing queryable thing, and we want to limit the number of potential properties so that we have more chance to zoom in on the right property.
Okay, nice. But then, I mean, so maybe I'm a beginner and it should be a newbie question, but let's say someone wants to compare versions of a document. So that would be a nice use case. I mean,
yeah.
Okay. But it's not possible yet, but that could be something that, I mean, could be handled later.
Yes. I mean, I really appreciate that people see this and think, oh, we could add this and this and this. And that's true. But let's also not forget that we have something that's already pretty impressive. At least I think it's pretty impressive.
No, yeah. I mean, and by the way, it's working locally. So
yes,
for me, in terms of performance, I see the gap because last year when we started to do LLMs and artificial intelligence demos on the Tech Talk Live, I know that Angel, for example, was struggling with what was at the time a very big laptop with a MacBook M1 Pro with 32 gigabytes of RAM and stuff like that. And for some demos, we had to rent some AWS.
Yes.
I mean, because just it was not possible to do everything. Plus, of course, sharing your screen requires a lot of resources. We often forget that. It's cool with a big gaming PC, but with a laptop, you're limited. So anyway, but yeah, no. So thanks, Guy. Last question from Steve Rayner. I mean, people, if you are attendees, if you need to drop, I mean, welcome. But we will just finish the quick question if you have some time, Hein or Boudewijn. But if you need to drop, let me know. It's 5 p.m. already. Steve Rayner, how easy to adapt the same concept to other ECMs, let's say OnBase or Nuxeo?
Excuse me. I think the concept can be easily adapted. I mean, the only Alfresco specific thing that we have is the API to we use the model API to pull down all of the types and all of the aspects. If there's a way to get to that in another repository, then we could use that. Nuxeo supports CMIS even, so it should be pretty easy. It should be pretty easy to adapt this to also work on Nuxeo.
Okay.
OnBase is indeed a bit of a different beast.
It doesn't support CMIS, for what I understand.
And that's not a deal breaker, but of course we've tuned this solution to produce CMIS. So that would be a bigger project to adapt this to OnBase.
Okay. I was looking at the chat. We have a question from Abhinav. I like it because it's always sensible when it comes to security and confidentiality of data. Is there a chance that the files we process goes outside of organization? When it's processing and execution, I would say, as a newbie, it's running locally. So as long as it's running on your laptop, it should be fine. But what happens, let's say, if you push your work into some public cloud? I mean, there will be some data transactions on. Is there a risk about that?
So even if you say, so imagine we turn this into a service. What we need, what we need to know is the list of properties. So that could be. So we don't even need to know. Well, no, we do need to know possible values, for instance. So that could be that could leak information if it. But we don't process documents or content, right? So what would go outside is the natural language query and the list of properties and their possible values.
Okay. But still, that could be a problem with the values.
Yeah. That could be a problem, yes.
Okay, very interesting. I think we are coming to the end of the question. I'm trying to refresh. This is not really a question. I think we are done with all the questions. So I think, guys, I can free you. Thank you very much. I know how much work it is to prepare this kind of demonstration. So anytime you come back to the Tech Talk Live, if you have, let's say, a big improvement or something very cool like that, you're always welcome. So have a nice day. Thank you, everybody who attended today, by the way. And of course, the recording will be available on Hyland Connect anytime soon, maybe by the end of the week if I have time. See you guys. Bye-bye.
Thank you. Bye-bye.